Hi, this is Mr. Adler, and welcome back to Ciencia on Fuego. Today, we're going to be talking about an extremely important property of matter, volume. Now, when I say volume, I'm not talking about sound. I don't mean like this is high volume and this is really low volume. I'm talking about something else. Let me demonstrate. Hi. I just increased the volume of this glove. Now I decreased the volume of the glove. Now, I did that by inflating it with air. When the glove was inflated, it had more volume. Now that it's deflated, it has less volume. Can you tell what volume is yet? Volume is a property that describes how much space an object takes up. So really huge objects like elephants have lots of volume, and really tiny objects like this rock, they have really low volume. Now, but don't confuse volume with mass, which is how much stuff or matter is in an object. I could have a big object, like a blown-up beach ball, that has really high volume, but not a lot of mass. There's not a lot of stuff in there. A bowling ball doesn't have that much volume. It's only about this big, but there's a lot of matter and mass shoved into it. Now, why is volume so important? It's so important because we use volume to measure how much of something we have. It's a really important measurement. For example, have you ever been watching a hospital show and they say, he needs 50 cc's of penicillin right now? A cc is a cubic centimeter. That's a way of measuring volume. If you need 50 cc's of penicillin and someone messes up the measurement and gives you 40, you're going to be in big trouble because you didn't get enough medicine. But how do we actually measure volume? And specifically, how do we measure the volume of a solid object? Well, there are two ways. First way is pretty simple. I can take a rectangular prism object and measure its length, width, and height. So here's my rectangular prism. It's got length, width, and then up and down height. And the way that I measure its volume, again, is measure the length, I measure the width, and last, I turn it to measure the height. If I multiply those three numbers, length, width, and height, I'm going to get the volume of this rectangular prism or box-shaped object. But the problem is many objects aren't box-shaped like this. In fact, most objects aren't box-shaped like this. What if I had an object like this rock? No matter how much I hold the rock up against the ruler, it's going to be really hard to find its length, width, and height. It doesn't have those nice, neat edges. We need another way to measure the volume of this object. Well, fortunately, a famous man named Archimedes figured this one out thousands of years ago in ancient Greece. The king of Syracuse asked, I want you to find me a way to measure the volume of my crown. The king was worried that someone slipped in other metals instead of gold when they said they were making him a gold crown. And Archimedes needed to find the density of the crown. Now, we can tackle density some other time, but for now, what you need to know is Archimedes wanted to measure the volume of the crown, how much space that crown took up. But crowns are a lot like rocks. They don't have nice, neat edges. Archimedes figured this one out while he was taking a bath. He got so excited that he famously jumped out of his bath and ran naked down the street yelling, Eureka! Which means, I found it. Now, what did he find? What he figured out was you can measure the volume of a solid object by how much water it displaces or moves. Let me show you. This beaker has about 800 milliliters of water in it. But look what happens when I put my fist in. Suddenly, the water level goes all the way up past 1,000 milliliters. Why? Well, the water takes up volume. The water takes up space, but so does my hand. My hand took up space, and the water took up space, so together they took up a lot more space. Let's start by putting 40 milliliters of water into my graduated cylinder. It doesn't have to be 40, but that's how I'm going to start. Once I've poured some water in, I bend down to make sure my measurements are perfect. I put in a little bit more than I wanted, so I'm going to pour some out. Use my dropper to be perfectly accurate. And now, there are pretty much exactly 40 milliliters of water inside my graduated cylinder. Now look what happens when I drop the rock in. I slide the rock in really carefully, making sure I don't splash. And now I'm going to read the volume again. Eureka. My volume was 40 milliliters, but now that I've added the rock, my volume is 42 milliliters. Now, the volume of the rock isn't 42. Most of that is water. I was at 40 milliliters, and then the rock displaced or moved the water just a little bit higher to 42 milliliters. So, what's the volume of my rock? It's that difference between 42, where I ended, and 40. And we know from math class, difference tells us we're going to subtract. I ended at 42 milliliters. I started at 40 milliliters. So I subtract, and I see that the volume of my rock is 2 cubic centimeters. I found the volume of the rock just like Archimedes found the volume of the crown. Now, whether you're measuring volume using a graduated cylinder or a ruler, remember, volume is an incredibly important property that measures how much space an object takes up. And I hope the next time you have to measure the volume of a solid object, you really measure up. Have a good day.